James C. Liao. James C. Liao Chinese, Liao Junjai is the Parsons Foundation Professor and Chair of the Department of Chemical and Biomolecular Engineering at the University of California. Liao has been recognized for the biosynthesis and production of higher alcohols such as isobutanol from sugars, cellulose, waste protein, or carbon dioxide. He was named the president of Academia Sinica, Taiwan in June 2016. Education and training. Liao holds both Taiwanese and American citizenship. After receiving his bachelor's degree from National Taiwan University in 1980, Liao earned his Doctor of Philosophy from University of Wisconsin-Madison in 1987 under the guidance of Edwin N. Lightfoot, co-author of Transport Phenomena. He worked as a research scientist for Eastman Kodak from 1987 to 1989. In 1990, he joined the Department of Chemical Engineering at Texas A&M University as an assistant professor, and 3 years later, he became an associate professor. In 1997, Liao became a professor for the Department of Chemical and Biomolecular Engineering at University of California, Los Angeles. Research. Liao's research interests include biological synthesis of fuels and chemicals, carbon and nitrogen assimilation, metabolic engineering and synthetic biology, transcriptional and metabolic networks analysis, fatty acid metabolism. Protein-based biofuels. Liao and his team are researching protein-based biofuels, which use proteins, rather than fats or carbohydrates, as a significant raw material for biorefining and biofuel production. The benefit of using protein is that the protein metabolism is much faster than fatty acid metabolisms, such as algae biofuels, which leads to higher production. Electrofuels. Liao's lab recently participated in the U.S. Department of Energy's Electrofuels program. They proposed converting solar energy into liquid fuels such as isobutanol. A new bioreactor could store electricity as liquid fuel with the help of a genetically engineered microbes and carbon dioxide. The isobutanol produced would have an energy density close to gasoline. Non-oxidative glycolysis. Liao has also worked on the creation of a non-oxidative glycolysis pathway. Natural metabolic pathways degrade sugars in an oxidative way that loses 1/3 of the carbon to CO2 in fermentation. The Liao laboratory has developed a pathway called non-oxidative glycolysis (NOG) that allows 100% carbon conservation in various fermentation processes. Awards and honors. Samson Prime Minister's Prize for Innovation in Alternative Energy and Smart Mobility for Transportation, Israel 2020. Elected to the World Academy of Sciences 2019. Elected to National Academy of Sciences 2015. Elected Academician of Academia Sinica. Industrial Application of Science from National Academy of Sciences 2014. Elected to National Academy of Engineering 2013. E&I Award for Renewable Energy 2013. White House Champion of Change in Renewable Energy 2012. Presidential Green Chemistry Award from EPA 2010. James E. Bailey Award, Society for Biological Engineering 2009. Alpha Chi Sigma Award, American Institute of Chemical Engineers 2009. 9. Marvin J. Johnson Award, Biochemical Technology Division, American Chemical Society, 2009. Charles Thom Award, Society for Industrial Microbiology, 2008. Merck Award for Metabolic Engineering, 2006. FBB Division Award of American Institute of Chemical Engineers, 2006. Fellow American Institute for Medical and Biological Engineering, 2002. National Science Foundation Young Investigator Award, 1992. Personal. 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 Liao is originally from Taiwan. He is married to Kelly Liao and has two daughters, Carol and Clara Liao.